This is the Edexcel GCSE paper 2 from Thursday the 8th of November 2018. So question 1, complete the Venn diagram. So we can see that we've got 8 in A, B and C. So that goes in the middle. Cross off the 8 so you've covered it. The only other number we have in common, we have the 20 being in both B and C. And then all the other numbers are unique to each of those sets. So A's got to include 2, 10 and 14. B has to include the 6. And C has to include the 18 and 22. So that's all the numbers from A, B and C, but you will see the universal set includes all the even numbers between 1 and 25. So starting off with 2, we need to have 4, we've had the 6, 8, 10, we need the 12, we've had the 14, we need the 16, 18, 20, 22 and 24. So there's our Venn diagram. Now for part B, a number is chosen at random from the universal set. Find the probability that the number is a member of A intersection B. So that means it's in both A and B. Well, there's only one number that's in both A and B. That's the number 8. So there's one of them. How many numbers in total in our Venn diagram? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 1 out of 12. Question 2. Well, there are two things that are wrong with this one. Firstly, that line of best fit has not been put through the centre of all the points. So by I, you need to try and make sure there's the same number of points above and below the line. Clearly what Sean's done here, he's forced it to go through 85, 140. So we need to go and say that the line of best fit, so the line of best fit is not placed correctly between all the points. Okay, there's no need to try and force it through this 85, 140. It should be going much more downwards, something like that. So you've got the same number of points left and right of the line of best fit. Clearly you would draw it with a ruler. The line of best fit is not placed correctly between all the points. Okay, now the second thing to note is the height scale is incorrect. Do you see how we jump from 140 up to 160, then to 170, 180? So it jumps up by 20 and then starts going up by 10. So the height scale is not linear. Okay, it's not going up by equal amounts each time, something like that. Question 3, well, we need to work out the size of angle X, which is one of the angles in this triangle. So to do so, we're going to have to work out the other two angles in the triangle. So why don't we start with this angle at the top first? Now, we know from the Z angle rule, in other words, alternate angles are equal, that those two angles there should be the same. So that angle there, 110 degrees, is the same as that angle there, 110 degrees. So that's 110, that whole big angle. So let's just give a reason for each stage as we go. So that angle there is going from C to B to E. So angle CBE equals 110 degrees. And the reason for that is alternate angles are equal. Excuse me. Alternate angles are equal. Now, because that's 110 degrees and that little component there of it is 35, we can see that angle EBG must be the difference between the two. So angle EGB equals 110, take away 35, which is 75 degrees. yes, 75 degrees. Okay. Now, what should we do next? So that's got that angle inside the triangle, so we know that. So what we're saying is we know that angle there, we just worked out, is 75 degrees. So, well, let's go and try and concentrate on the bottom. Now, at the bottom, we know that angles on a straight line add up to 180 degrees. So that angle all the way around there must be 70 degrees, because angles on a straight line total 180. So let's go and explain that. So angle from B to E to F, BEF equals 70 degrees, because angles on a straight line total 180 degrees. So if that's the angle all the way around, then this angle in the triangle, angle BEG, so BEG must equal 70, take away 25, which is 45 degrees. So we know, we now know both the angles inside the triangle, two of the angles inside the triangle are 45 and 75. So we can now say that X equals 180, take away 45 and take away 75, which is 45 and 75 is 120, from 180 is 60 degrees. So X is 60 degrees. How did we know this? This is because angles in a triangle total 180 degrees. So you did have to give a reason for each stage of the working. So you must say alternate angles are equal, angles in a straight line total 180, and angles in a triangle total 180. There are other ways to answer it. You may have done collinear angles and so on. So as long as you've explained each step of your workings, and as long as you've got 60 degrees, you'll be fine. Question 4, part A. So Ali invests £2,000 in the cash savings account, compound interest 3 years. So let's take Ali's £2,000. Now, because the interest rate was 2.5%, the multiplier is going to be 1.025. It was invested for 3 years, so that's to the power of 3. So just popping that into your calculator, £2,000 times 1.025 to the power of 3 gives us 2153.78 pounds. Now that's the total that Ali has after 3 years. So the interest is that amount less than money invested in the first place. So that's £153.78. So that's the interest that Ali got. Now moving on to Ben. So Ben went and invested £1,600, also compound interest, also 3 years, 3.5% interest, so 1.035 to the power of 3. So 1600 multiplied by 1.035 to the power of 3 gives us 1,773, rounding to the nearest penny, 95. So that's the total amount Ben had after the 3 years, including the money he invested. So the actual interest he earned is the difference between the two, which is going to be £173.95. So clearly we can see that Ben's got more interest. So what does the question say? Work out who will get the most interest by the end of 3 years. So Ben gets the most interest. Okay, now in the third year, the rate of interest for the shares account is changed to 4%. Now the shares account is the one that Ben was using. So Ben already had got the most amount of interest. He's just going to be getting even more interest. So for part B, does this affect who will get the most interest by the end of 3 years? No, it doesn't. Now, note what it asks. It doesn't ask you to work out how much extra interest or anything. It's only worth 1 mark. So just say, does this affect who will get the most amount of interest? No, it doesn't. No, it doesn't. Okay, so we just need to make the point that Ben already had the most. He's just going to have even more now. Ben already had the greatest amount of interest. He just now has more, something like that. That would be absolutely fine. It's only worth a mark, and you're just making the point that you understand that Ben is getting extra money. He already had the most. Question 5. So first of all, let's just see how much square footage that John has got to paint. So what's the area of that floor? Now, to work out the area of a trapezium, you average the parallel sides. So you average the 10 and the 16, so add those together and halve them, and you multiply this by the distance between the two parallel sides. So we're multiplying that by 7. So the average of 10 and 16 is 13. So this is just 13 times 7, which is 91 meters squared. So that's the amount of floor that needs to be painted. Now we're told that 1 litre of paint covers an area of 2 meters squared. So how many litres of paint are we going to need? It's going to be 91 divided by 2, which is 45.5 litres of paint. Now look, this is where you've got to be really careful, okay? Each tin of paint paints 5 litres, okay? Now 9 tins of paint is almost enough, because 9 fives are 45, but you're just going to have to buy that 10th tin, and okay, you're going to have lots left over, but you can't just go in and pour a little bit out of the tin. So the key thing is that we need to buy 10 tins. Okay, now that's going to cost us 10 lots of £16.99, because it's £16.99 a tin, so that's £169.90. Now, because John has only got £160 to spend and paint, he does not have enough money. So John does not have enough money. Ten tins costs £169.90, but he only has £160. Had he been able to just pour out a little bit of paint and just pay for what he took, then he would have had enough money, but clearly you can't go and do that. Question 6, and we're told the gradient of the line AB is 3. So let's just do a quick sketch to help us gather our thoughts. So the coordinate A is at 5, 9, so let's go and pop that down here somewhere. So the coordinate A is 5 along the corridor, 9 up the stairs. We're told that the gradient of the line is 3, so that's sort of going upwards, left to right. And we're told that the coordinates of B is D along the corridor, 15 up the stairs. Now, to work out the gradient of a line, it is the y step divided by the x step when you pop in a triangle. So let's just go and pop in a triangle. So let's pop in this triangle here. Now our y step, the height of the triangle, is 15 take away 9, which is 6. Now the gradient, okay, the gradient, as I said, is the y step over the x step. So that is 6 over the base of our triangle, this length here. And when we do y step over x step, we're going to get a gradient of 3. Okay, so what must we be dividing 6 by in order to get a gradient of 3? Well, clearly it's going to have to be 2. The base of our triangle is going to be 2. So, given that A was 5 along the x-axis and D is a further 2 along the axis, D must be equal to 7. So question 7, well, you might well just be able to pop this into your calculator and just press equals and use the standard form information, but let's just double check you would be able to do this if it was on a non-calculator paper. So first rule of standard form, the first number must be between 1 and 10, so where would you put the decimal point to get it between 1 and 10? It would be between the 8 and the 6, so that would be 8.623. Now it's a small number, so the power is going to be negative, and the decimal point is now going to be between the 8 and the 6, having been over here first. So how many hops is that? 1, 2, 3, 4, 5 hops. So that's 8.623 times 10 to the minus 5. Now for part B, you're just going to need to pop this into your calculator to get the actual normal number. So make sure you use the fractions button, which is the third one down on most standard calculators, and then you're taking advantage of using the times 10 to the power of button, which for most calculators is right down at the bottom in the middle. So if you just go and pop all this into your calculator, then you're going to get 744,1860.5 and so on. Okay, so we've got to give our answer correct to 3 significant figures in standard form. So again, the first number's got to be between 1 and 10. So that's going to be 7 point something. Now 3 significant figures, so that's 7.44 times 10 to the positive power on this occasion. So the decimal point in the normal number is between the 0 and the 5. We need to move it to there, between the 7 and the 4. That's 1, 2, 3, 4, 5, 6 hops. So 7.4 times 10 to the power of 6. So question 8. Well, I've had to go and just pop the lines in before I started the video here. Otherwise I just can't do it accurately enough. So the first thing I've gone and drawn here is the line y equals minus x. That is y equals minus x. That's where the x coordinates and the y coordinates are the same but with a change of sign. So minus 1, 1, minus 2, 2, and so on. So we can then just reflect our points across. So that point there goes to there. That one there is 1, 2, 3 on the diagonal, 1, 2, 3 on the diagonal. And then that point here is 1, 2, 3, 4 on the diagonal, 1, 2, 3, 4 on the diagonal to here. So when you go and reflect triangle P in the line y equals minus x, you get that shape there, which we're calling triangle Q. Now we then had to go and reflect triangle Q and the line y equals x equals minus 1. Now be very careful, that is the line x equals minus 1. It is parallel to the y-axis, okay, not parallel to the x-axis. All the x coordinates on that purple line are minus 1. So once you've got that in place, it's easy enough just to reflect it across. Why don't we just change colour for it? Let's just do this in red. So that coordinate is 2 away, so we go 2 away to there. That is 2 away, so 2 away to there. That is 1, 2, 3, 4 from the mirror line, 1, 2, 3, 4 to the mirror line. So that takes us to that triangle there. So that is triangle, so that's triangle R. Okay, now the question is actually asking us to describe fully the single transformation that maps triangle R on to triangle P. So R to P. Now it's a rotation. We can see it's rotating from R round to P. A little tip: the centre of rotation is always going to be where your 2 reflection lines have crossed. So our centre of rotation is going to be minus 1, 1. Now you've got to be careful, because we're going from R to P, that is 90 degrees anti-clockwise. So to pick up all the marks here, you need to set its rotation by 90 degrees anti-clockwise. About the point minus 1, 1. Okay, question 9. So Martin truncates the number n to one digit. The result is 7. So now when we're truncating it, we're just literally cutting the number off. So at 7.999 recurring, you're still just going to be saying, as you cut the number off, that is 7. Okay, and similarly, when you're just over 7, okay, you're going to be truncating it and calling it 7. In fact, even at just exactly on 7, you're going to be cutting it off and calling it exactly 7. So error interval wise, we're saying n has got to be greater than or equal to 7, because at 7 you actually truncate it still to 7. So n has got to be greater than or equal to 7. Remember, you read that bit from the center, you're reading that right to left. But n does have to be just a fraction under 8. At 8, it would truncate to 8. So n's got to be less than 8. So make sure you get those inequality signs the right way around. Okay, that is n is greater than or equal to 7, but less than 8. Okay, so it's yellow to blue paint. The ratio of yellow to blue is 2 to 3, and we're going to make 50 litres of green paint. So yellow and blue, when it's mixed together, gives us the green paint. So 2 to 3 to 5. So to make 50 litres of paint, multiplying everything by 10, we're going to need 20 yellow and 30 blue to make 50 lots of green. Now the yellow paint, okay, we buy that in 5 litre tins. Okay, that we buy that in 5 litre tins. So we're clearly going to have to buy 4 tins, and it's £26 a tin. So 4 times 26, 4 times 26. So the yellow paint is going to cost us £104. Now the blue paint we buy in 10 litre tins. So clearly, as we need 30 litres, we're going to need to buy 3 tins. They cost £48 each. So the blue paint is going to cost us £144. So the total cost of the yellow paint and the blue paint is the 104, add the 144, which is £248. So that's how much it's going to cost us. Now we go and sell this in 10 litre tins. We sell in 10 litre tins. Okay, we've made 50 litres. So we're going to sell 5 tins. We're going to sell 5 tins, each costing £66.96. So the actual money we have coming in is £334.80. Now, to work out a percentage profit, it says on each tin of green paint, but it's a percentage profit, so we can just work it out on all 5 tins. It's the same percentage. So let's work out the percentage profit across all 5 tins. So to work out a percentage profit, it's the actual profit you make divided by the original cost, and then you multiply that by 100 to turn it into a percentage. So our profit is going to be the money we took selling it, which is £334.80, taking away our cost of 248, divided by that £248 cost, and we times that by 100 to turn it into a percentage. 334.80 minus 248 is £86.80. So divide that by the original cost of 248, turn it into a percentage, and we get exactly 35%. Okay, so let's go and work out all the various combinations. So a starter dish and a main. So a starter and a main. Well, there are 9 starters, there are 15 mains, so 9 times 15 is 135 combinations. Now alternatively, we could have a main and a dessert. Okay, we've got 15 mains, 8 desserts, 15 times 8 is 120. So there's 120 ways you could have a combination of a main and a dessert. And then finally, Janet may have a starter, a main and a dessert. So that's 9 times 15 times 8. So multiplying those together, we get 1080. So those are the various combinations. You add the three of those together and you go and get the 1335 different ways to choose the meal, which is what we had to show. 12 part A, so let's fully factorise the numerator of the first term. Now this is the difference between two squares, so this is that 4x squared minus 9 is a 2x plus 3, 2x minus 3, and the denominator we can factorise and take a 3 outside the bracket, leaving us with a 2x plus 3, and then we can factorise the denominator of the right hand side to give us that. Now at this point we can see that the 2x plus 3 cancels with the 2x plus 3 and the x cancels with the x. Now we can't cancel out any more, so let's just go and multiply out the numerator. So 2 lots of 2x minus 3 is 4x minus 6, and 3 lots of x minus 3 is 3x minus 9. For part B, we're going to need to have a common denominator throughout to add and subtract fractions. So I'm just going to give myself a bit more working room. So I'm going to have 3 over x plus 1 is my first term. Then I'm adding 1 over x minus 2, then I'm subtracting 4 over x. That's really my starting point. Now I'm going to need to have a common denominator throughout of x plus 1, x minus 2 and x. So with this first term I'm going to need to have an x minus 2 and an additional x. So clearly if I've done that to the denominator, I have to do that to the numerator as well. My second term is going to need to have an x plus 1 and an x, so an x plus 1 and an x, and then my third term needs to have the x minus 2 and the x plus 1, and that's, x minus 2 and x plus 1, and that's given me the common denominator throughout. So if I go and multiply out now, okay, so I'm going to get 3, so I've got 3x squared minus 6x from that first term, and then from the second one I'm adding on an x squared and an x, and then from this third one, a bit more work going on here, haven't I? So x minus 2 multiplied by x plus 1, so just the red bit, gives me x squared minus 2x, x squared plus x minus 2x is minus x, and then minus 2 on the end, and then multiplying all of those components by minus 4, I get minus 4x squared, add 4x, and add 8, and all of that is over my common denominator of x plus 1, x minus 2. So gathering up my like terms, I've got 3x squared, add x squared, minus 4x squared, so the x squareds all cancel out, minus 6x plus 4x is minus x, so that's minus 6x plus x plus 4x is the minus x, and then I've got the plus 8 on the end, and that's all over my common denominator of x plus 1, x minus 2. It probably wasn't actually helpful to have crossed out those up there. I just really did that so you could see which ones I was doing. I wouldn't cross out actually in a test unless I was cancelling like I was up in part A. Alright, so please don't put the lines through here. I was just illustrating the point that I was gathering like terms. And that's your final answer. Mine is x plus 8 all over x, x plus 1, x minus 2. Question 13. We're told the circle has a circumference of 44. Now circumference equals the pi times diameter. So the diameter is the circumference divided by pi. So our diameter is 44 divided by pi. Now I'm just going to leave it like that, as that's an exact number. Now to work out the area of this equilateral triangle, so the area of the triangle is going to be half times the base times the perpendicular height. So let's slot in what I already know. I've just worked out that the length of the base, which is the diameter of the circle, is 44 pi. So I now just need to work out what the perpendicular height of the triangle is. Whoops, why can't I get the colour up? So I need to work out this height here. This is the perpendicular height, which I'm going to call x. So just extracting this triangle over here, so we can just gather our thoughts. I want to work out the height, which is x. Now this hypotenuse is another side of the equilateral triangle. So that's 44 over pi. And the base of this triangle here is half the diameter, which is 22 over pi. So using a taking away Pythagoras, I can say that x squared equals 44 over pi all squared, take away 22 over pi all squared. So popping that into my calculator, so I've got 44 over pi all squared, taking away 22 over pi all squared gives me 147.118 ... So square rooting both sides, I get 12.129 ... So that's my perpendicular height. So let's take that back up to here. Now I've still got that exactly in my calculator, so if I multiply that by 44, divide that by pi, and then multiply that by 0.5, I'm getting 84.9388. So read the question, give your answer to 3 significant figures. That's a final answer of 84.9. Okay, so this is one of these exponential graphs. Now think about it. When x is very big, 2 to the power of something very big is going to be very big. So we're coming in from here. Now, when we get down to like x being 3, we're going to have 8. When x is 2, we're going to have 4, and so on. Now, when we get x being 0, 2 to the power of 0 is 1. So all these exponential graphs always cross the axis, regardless of what this base number here is, at the point 1. Now 2 to the power of minus 1 is a half, 2 to the power of minus 2 is a quarter, and so on. So this exponential graph is going to keep on getting closer and closer to the x-axis, but will never actually get there. Okay, so that is the shape of your exponential graph. You can put in that there is an asymptote here, a dotted line along the x-axis, to suggest that you're never actually going to reach that. But looking at the mark scheme, it doesn't seem to be requiring you to put in the asymptote. Okay, it just says sketch a graph which starts above the x-axis for negative x, makes an increasing exponential rise. Yep, and then the second mark was for labeling the point 0, 1. So that is all we need to do for the 2 marks. So question 15 just requires you to appreciate that x squared plus y squared equaling the radius squared is the equation of a circle with the centre 0, 0 and obviously r being the radius. So what we've been given here, that 42.25 is the radius squared. So we just need to square root 42.25 to get our answer. So the square root of 42.25 is 13 over 2, which is 6.5. So question 16 part A, we need to work out the probability they get different colours. So Joe's taking the first pick and then Mary's taking the second pick. So we need to work out the probability that Joe takes a red and then Mary gets a blue, or it could be the other way around. Joe gets a blue and then Mary gets a red. So the chances of Joe getting a red is 0.65. It goes back into the bag, so the probability of Mary then getting a blue is the rest is 0.35, and then vice versa. So 0.35, Joe getting a Joe getting a blue, and then 0.65, Mary getting a red. So 0.65 times 0.35 is 0.2275. So we've obviously got two of those. Add those together, we get 0.455. Okay, so for part B, so red to blue, the probabilities are 0.65 and 0.35. But we're told there are actually 78 reds, and we want to work out how many blues. So how do we get from our left hand column to the right hand column? We need to take our 78, divide it by 0.65, and then multiply that by 0.35. So 78 divided by 0.65 equals times 0.35, I get 42. So we are told when we subtract 5 from P and subtract 5 from Q, the ratio is 5 to 1. So therefore P minus 5, that's taking 5 off P, to Q minus 5 is the ratio 5 to 1. Now this is the clever bit. We want to create an equation here. We want to construct an equation. Now the right hand side is 5 times smaller. So in order to make these two sides equal, we have to multiply the right hand side by 5, and then they are equal. So we can say P minus 5 equals 5 lots of Q minus 5. So that's the key step, going from a ratio to an equation. So we multiply out the brackets. P minus 5 equals 5Q minus 25. Add 5 to both sides. We get our first equation. Okay, P equals 5Q minus 20. Now we're given a second fact. We're told that when you add 20 to P and add 20 to Q, the ratio is 5 to 2. So let's do a similar thing. So P plus 20 and Q plus 20, the ratio is 5 to 2. So same idea here, we want to make both of these equal. So if we multiply the left hand side by 2, we get 10 lots, and multiply the right hand side by 5, we also get 10 lots. They are then equal. So 2 lots of P plus 2, of P plus 20 rather, so 2 lots of P plus 20 plus 5 lots of Q plus 20, they equal each other. Okay, so 2 lots of P plus 20 equals 5 lots of Q plus 20. Okay, so multiply out both brackets, so 2P plus 40 equals 5Q plus 100. Take away 40 from both sides, you get 2P equaling 5Q plus 60. And I'm going to call this equation number 2. So if I go and substitute equation 1 into equation 2, so substitute 1 into 2, Okay, so 2 lots of P, so 2 lots of 5Q minus 20 equals 5Q plus 60. Multiply out the left hand side, 10Q minus 40 equals 5Q plus 60. So add 40 to both sides and take away 5Q from both sides. We get 5Q equaling 100. So Q equals 20. So Q equals 20. So Q equals 20, but we know that P equals 5Q minus 20 from equation 1. P equals 5Q minus 20. We've just worked out that Q is 20. So P is 5 lots of 20, which is 100 minus 20. So P equals 80. So our P to Q, so P to Q, we're not asked to work out what P and Q are. We're asked to find the ratio P to Q. So we know P to Q. We know that P is 80 and Q is 20. So writing this ratio in its simplest form, dividing both sides by 20, our final ratio, our final answer is the ratio 4:1. Question 18. So let's look at L1. And I think a little sketch always helps us gather our thoughts with the gradient. So we've got our first point at 4, 6. Our second point at 12, 2. So there's our line L1. Now just draw in a gradient. Draw in a triangle to help you work out the gradient. So the x coordinate is going from 4 to 12, which is the length of 8. And our y coordinate is going from 2 to 6, which is the length of 4. Now our gradient is always the y step over the x step, which is 4 over 8. But note how the line is going downhill. So that's a minus 4 over 8. So minus a half. Now using y minus y1, y minus y1 equals mx minus x1, very useful formula, more powerful than y equals mx plus c. x1, y1 is any point on the line, and m is the gradient. So let's use the 4, 6. So y minus the y coordinate of 4, 6, so y minus 6 equals the gradient, x minus the x coordinate of 4, 6. So multiply out our right hand side, and we get that. And then adding 6 to both sides, we get y equals minus a half x plus 8. So that is our line L1. Now let's move on to L2. Now with L2, we are told that it passes through the origin and has gradient minus 3. So we might as well use the good old-fashioned y equals mx plus c for this. Okay, so the gradient is minus 3. And because it passes through the origin, the y-intercept is 0. So that is our line 2. Now we need to find where these two lines intersect. So they intersect just solve the simultaneous equation. They're both y equals something, so just set them equal to each other. So they intersect where minus a half x plus 8 equals minus 3x. Okay, so add a half x to both sides. So 8 equals minus 2.5 minus 5 over 2x. Multiply both sides by minus 2, divide by 5, we get x equaling minus 16 over 5. So that is our x coordinate. Now I still need to go and work out my y coordinates. What colour shall we use? Let's use green. So we know that y, whoops, the green didn't work, never mind. Y equals minus 3x. Just from L2, we could have used our first equation. We've just worked out that x is minus 16 over 5. Minus 3 times minus 16 is 48, so 48 over 5. So our final answer is minus 16 over 5, 48 over 5. Question 19. So let's start off by making m squared the subject. So multiply everything by 4 to get rid of that dividing by 4. So 88 is less than m squared plus 7 is less than 128. And to undo this adding by 7, let's take away 7 from both sides. So 81 is less than m squared is less than 121. Now when we square root, the square root of 81 gives us both plus 9 and minus 9. And when we square root 121, we get both 11 and minus 11. So those are our 4 critical values. So I think just some little sketches to help us gather our thoughts is always helpful. So let's start off with the minus 9 and the minus 11. And this is a positive parabola. This m squared is a positive parabola, so a smiley face. So let's just go and pop it in our positive parabola. And I'm just going to go and consider the value in the middle. Just think about minus 10. Now minus 10 squared is 100. Is that a value I want? Yes, I do, because 100 is between 81 and 121. So that is a wanted value. So the set of values I want are the values below the x-axis. So my first set of values is where x is less than minus 9 but greater than minus 11. And then let's think about our other 2 critical values of 9 and 11. So another sketch just to doubly make sure. So that's going through 9 and 11. Again, just think about 10. So 10 squared is 100. Yes, 100 is between 81 and 121. So 10 is a wanted value. So again, the set of values I want here are the lines, set of values below the x-axis. So that is where x is less than 11 but greater than 9. And that's my final answer. Question 20. So we've got a lot to do here. So let's start off by working out the volume if it was a complete cone without the top bit cut off. So the volume of the whole cone, okay, so that's we can see that the volume of a cone is the third pi r squared h. So that's the third pi and the radius, obviously, of the whole cone is half of 7.2, so that's 3.6 squared. And then obviously the total height, if it was a whole cone, is the 3.2 add the 3.2, which is a 6.4. Pop that into your calculator, you get 86.8587 ... Now what about the volume of the cut off part of the cone? Now before I start doing that, you've got to appreciate that really we've got similar triangles here. If you consider the bit that's cut off and you consider the whole of the cone, just looking at it in 2-dimensionally, has got a base of 7.2 and a height of 6.4. Now we know that the cone part that's cut off has got a height of 3.2, so it's a similar triangle. That's half the height, so it's going to have half the diameter. So the diameter is going to be 3.6 for the part of the cone that is cut off. So that has a diameter of 3.6, so obviously a radius of 1.8. So the volume of the cut off bit, let's just pop that in speech marks, that's not very good English, the cut off cone. So that's the third pi 1.8 squared times the height of 3.2, giving us the volume of the cut off bit being 10.8573. So the volume of the frustum is obviously 1 take away 2, the 86 take away the 10, which is 76.001. Okay, so let's move on. Let's change colour. Let's go and move on to the hemisphere. So the volume of the hemisphere Okay, that's the half the football. Now the volume of a whole sphere is 4/3 pi r cubed. So half the football is going to be 2/3 pi r cubed. So that's 2/3 times pi, and then the radius again is going to be half of the 7.2 is going to be the 3.6 being cubed, which is 97.716. Now for future reference, let's say the volume, let's call the volume of the frustrum 3 and the volume of the hemisphere 4. Okay, now so we now need to go and work out take into account the densities, the masses and the volumes. So I just need to slide this page down a bit. So hopefully I can do that like that. Excellent, good. Right, so back to density, the mass and the volume. Now we know that density, let's do this in black, density no, it's not in black yet, let's do it in black. Density equals mass over volume, got to learn that. Okay, so rearranging that, mass equals density times volume. So for the mass of the frustrum, we take the density of the frustrum that we've been given is 2.4. Just check the units are all okay and there's not an added complication. They're not. It's centimetres cubed. We've been working in centimetres cubed, so that's a relief. So the mass of the frustrum is going to be the density of the frustrum, 2.4, times the volume of the frustrum, which we worked out to be that 76.001, giving us a mass of the frustrum of 182.40. I'm going to call that equation 5 for future reference. Similarly, the mass of the hemisphere is going to be the density of the hemisphere, 4.8, times the volume of the hemisphere, which was the 97.716, which gives us 469.037. Let's call that equation 6 for future reference. Okay, so my total mass is 5 plus 6, which is 651.4. Now my total volume is obviously going back to my two volume calculations is 2 plus 3. My total volume is my my total volume, is my volume of the frustrum. So 3 plus 4, I should say, shouldn't I? Not 2 plus 3, 3 plus 4. So the total volume is the volume of the frustrum, which was 3, plus the volume of the hemisphere, which was 4, giving me 173.7. Okay, that was the 76.001 at the 97.716. So we can finally work out the average density, the density of the total object. That's going to be the mass of the total object divided by the volume of the total object. So that's my 651.4 divided by my 173.7, which gives me 3.749. So I'm going to do to two significant figures, I'm going to do 3.75. Now the mark scheme allowed any answers between 3.7 to 3.8 because it was obviously very easy to lose some accuracy as you worked your way through. Question 21. Now this is okay if you spotted that CAORC is a cyclic quad. So let's just make this clear on the diagram. So C to A to O to R to D. Now that's a four-sided shape with all four corners sitting on the left-hand side circle. So that's a cyclic quad. So let's go and choose to let that angle there be X. So let angle C to A to B, let C to A to B equal X. And then what do we know about cyclic quads? Well, opposite angles add up to 180. So that angle there will be 180 minus x. So then angle C to R to O, C to R to O equals 180 minus x, because opposite angles of a cyclic quadrilateral total 180 degrees. Now that's the hard bit done then, really, because following on from that angle there, whoops, let's change colour, that angle there must be x degrees, because obviously angles on a straight line add up to 180. So we can say angle O to R to B equals x degrees, because angles on a straight line Now, if we then just go and focus on this triangle O to R to B, OR and OB are both radii of the right hand side circle, so they are of the same length, so therefore the two base angles must be equal, so that angle must be x as well. Okay, so we can then say angle A to B to C equals x, because base angles of isosceles triangle, and I might just spell out what the isosceles triangle was. I don't think I need to, but I think I will. ORB. So base angles of isosceles triangle ORB are equal. So we've shown that both CAB equals x and ABC equals x. So we've therefore proven that angle CAB equals angle ABC. So, okay if you went and spotted that this cyclic quad was there.